is to create consistent, predictable mass data based on predefined database tables with candidate data. Going forward, these tables will be referred to as lookup tables. In a nutshell, you replace known production data with pre-created obfuscated data. The way the system works is by matching values in order to establish which row in the lookup table specified is linked to a given row in the target database. This can be any field within a given table, whether this is an integer, a string, or any other data type. Once a link has been established between a row in the test dataset and a row in the lookup table, we can replace one or more columns within this row with column values from the lookup table. This process is then repeated for every single row in the original table, resulting in the included columns in the original table being masked. If a row does not match a row in the lookup table, the columns specified are altered by a backup function, which the user can specify. One key benefit of this system is that it allows the user to replace multiple columns simultaneously, and this is ideal for situations where multiple columns have a logical relation to one another. An example of this would be data such as postal codes, place names, and streets. These three are always linked together physically in the real world. If we generated these values individually, privacy wouldn't know how to match newly generated postal codes to their corresponding place names and street names. However, because we take a per-row approach to masking data for the value lookup function, these logical correlations are preserved and we generate usable, realistic data. One downside to this function is that it requires the user to build and maintain lookup tables. Not only does this process require some manual effort to initially create, but over time, new rows might be added into the original table that do not match a row within the lookup table. And this would result in more and more rows being relegated to being modified by the backup function. If you match rows based on predictable data such as an iterating integer, say a primary key, you can mitigate this downside by making sure you have a wide margin of integers in your lookup table to match as the original table grows in size. Now that we know the theory behind the value lookup function, let's put our knowledge into practice by creating the example function from the presentation. So we have a simple project here. Let's switch to the masking tab. And this contains two tables. It contains our test data table, which is the table we want to mask. And this is quite a simple table. It contains an ID, a street name, a city name, and a postal code. We also have a lookup table. And this is practically the same table. The only difference being that all of the column names are appended by lookup, and the table is filled with synthetic data. We don't actually need to import the lookup table for this project, so let's go ahead and delete it for now. Now in the test data table, select the street column, press add function, and value lookup. So first we have to specify which table we want to use as a lookup table. We do this by designating the database, YB-tier1, then the schema, public, and then the table name. Now that we know which table we want to look in, we need to configure the input mapping. The input mapping is basically which columns do we want to compare between the two tables to establish links. So we want to use the ID in our original table and then check that against the ID in the lookup table. And we've named this the lookup ID. So what this configuration means is for every row, we check whether ID in the test data table is equal to the lookup ID in the lookup table. And if this is true, then we have a match. And once we have a match, we need to determine what we do with the data in these rows, because we're going to be exchanging data. To do this, we use the output mapping. Here we can select a column, for instance, our street, and then specify which column we need to use to replace the value if there's a match. So here we'll be doing our lookup street. Save our row. And let's do this again for all the other values we have. So we'll say city we want to replace with lookup city, and postal code we want to replace with lookup postal code. So just to summarize, if the ID in a test data table is equal to the ID in the lookup table, for every column within that row, we replace the street value with the lookup street value, and so on and so forth for all of the various columns that are here. If there's no match, we need to specify a backup function. And we can do this under the if value not found, then column. And there's a few options here. The first option is that we can just ignore the function and say, let's just leave our original value unmasked the way it was. The second option is making it blank. What this does is just changes the contents of this column to null. The third option is using a expression. Expression is a simple SQL script that you can define yourself. And the last option is scrambling. And this just turns all of the letters to X's and all of the numbers to nines. So let's scramble all of these. So now our function is confined. We can press OK. And we should be able to just deploy this. Let's go to deployment, press start, select masking. And while this is running, this might take a moment. So let's pause and I'll get back to you once we're done. All right, welcome back. Now that we're done, we can see that the step is completed. We've completed our value lookup function and we've masked 10,000 rows. And if we look at the bottom logging here, we can also see that 10,000 rows were affected. So now you should know how to configure a basic value lookup function and use this in order to mask entire rows, replacing multiple column values simultaneously.